Okay, so now we get down to what this integration, this definite integral stuff is really all about, okay? And as you can see here, I've got a graph drawn. The graph is the function f of x, it's a curve, okay? F of x can be basically any function. And I've got my axes drawn in, x-axis, y-axis, and I've got an area shaded here, which is underneath the graph, okay? Or more precisely, it's the area which is sort of locked in between the x-axis, the graph function, and these two lines, which are x equals a, okay, so that's that line there, and x equals b, okay, so the line of b up and a up, okay, which are at these two numbers here, a and b. They could be anything again, okay, and this area here is calculated using, guess what, the definite integral, okay, so we've got the definite integral of f of x dx between the limits of a, which is the lower limit, and b, which is the upper limit, okay. So this is part of what's known as the fundamental theorem of calculus, and that says basically that the area underneath the graph is just the definite integral of that function with the limits put in, okay. That's not such a difficult idea, but very, very useful, because now we can find areas under graphs which don't have easy shapes. You know, there's not a circle, it's not a square, it's not a rectangle, it's not a triangle, it's not a shape which you know how to calculate. It's some function. It could be any function, any polynomial function, in fact any function basically, okay. And this is it. This is the important thing here. So we know how to calculate these now, these definite integrals. We integrate and we put this number in, then we subtract this number in, and what comes out gives us our area, okay. It's very interesting to find out how this works, where it comes from. Unfortunately this year especially we don't have time, but we do need to practice these, okay. So what I'm going to do next is do a quick practice. Here's one I made earlier. This is the function x squared plus 1, y equals x squared plus 1, so it's a parabola. It's shifted up by 1, so in fact this point here would be the point y equals 1, and I want to find the area under this graph between the lines 1 and 3, okay. So all we do is we do the definite integral. 1 is our lower limit, 3 is the upper limit, and the function is x squared plus 1. Don't forget to indicate the variable, okay. Now you'll see a lot of times this is put in a bracket just to say that this dx is for the whole thing. Whether or not it's necessary, I don't know, it depends really. But anyway, that's what we're calculating. So this area here is the definite integral between the limits 1 and 3 of the function, okay. So fairly straightforward integral here. That becomes x cubed over 3, and that's plus x, same limits, 3 and 1, okay. So I will continue that up here. So again, what do we do first? We put the number 3 in, okay, so we put 3 in for x. So we've got 3 cubed, which is 27 over 3 plus 3, and we're taking away from that 1. 1 cubed is 1, so that's 1 over 3 plus 1, okay. 27 over 3, that's not too bad, that's 9, plus 3 is 12, 12 minus 1 and a third, okay, so minus 1 and a third, so that's going to give us 10 and 2 thirds, Okay, so that 10 and 2/3 is the area of this bit of the graph here, this bit underneath the graph, sorry. In fact, yeah, more strictly, let's say that again. It's not actually the area under the graph, because that would go on forever, but it's the area between the function here, these two lines where x is 1 and x is 3, and the x-axis. Okay, so this shaded area anyway. So the shaded area is calculated using the definite integral. Okay. Okay, so now you can go back to that sheet you've been doing, and you can try some of the questions after number 2. Basically, you can do numbers 3, 4, 5 maybe. Okay, so one last thing I'd like to show you though, however, is what do you do if you have a graph like this? Now here, I've got this line here, A, but then the graph crosses the x-axis and it goes underneath the x-axis up to the point C, and then between C and D it's on top of the x-axis again. So it looks a little bit like some kind of trigonometric function. Okay, but the important point here is, if I want to find the area basically bounded, you know, this shaded area, some of it's above, some of it's below the x-axis, but I want to find the whole area, what I can't do is do this. Integrate from A all the way to D of this function. Okay, that would not give me the total area. Okay, if the total area is this one plus this one plus this one, okay, these three areas added together, no, cannot do this, and there is reason for that. Okay, this area here is above the x-axis, it's positive. This area here is above the x-axis, it's positive. This area here is beneath, it's below the x-axis, and when you do an integration it's negative. Okay, so these areas have signs attached to them. So if you calculated these three areas, these two would add together, but this one would subtract itself, so it wouldn't give you the correct answer. Alright, to get the correct answer you need to make all of these three areas positive and add them all together. So you'd have to do a modulus sign. You have to make sure you know that this is negative and change it to be positive. So how do we get around that? Well, we don't just have the limits A and D. If you look closely, we have A, B, C and D, and we have 1, 2, 3 separate areas. So in a situation like this where part of it is below, we have to do 3 separate definite integrals. So we'd have to do something like this. We'd say that the area is the integral from A to B of f of x plus and you'll see what I'm doing here in a second, the modulus of from B to C of f of x. In fact, I'm going to do dx all at the end. Okay. Now this here is a modulus sign. That means that when this gives us a negative answer, and it will do, if you later on you'll see that any area below the axis gives you a negative. So I need to make it positive so that it adds up with the others. And then I've got lastly plus the integral from C to D of f of x, and all of those are with the dx. So really this should be after each one, but I'll just put it in at the end. Okay, so in a situation where you've got areas, some are below and some are above, you must take each area by itself. Okay, and some of them will be negative. This one, if we calculate this, we'd find it was a negative number. So we have to remember that when we see a negative number, you can't have negative area. It doesn't mean anything. So you have to say, okay, well let's change that to be positive and add it to the other two. Okay? A question like this might look all rather confusing. it'll be much easier in practice. Okay, so that's just something to note, because there are a couple of questions where you have to think about negative areas, but we'll do some more examples of this, not today, another lesson. Okay, today I want you to focus just on understanding this idea here of these areas under graphs. Yeah, that's the whole point. This definite integral is area under graph, and exactly the same way. So far you got this stuff you know now, right? If you see integral, you do it, and you put the numbers in, and you get an answer. Okay. All we're really doing today is saying, what does this mean? Well, this means this. Okay. This definite integral of a function between two numbers is basically the area underneath the graph between two lines, you know, two x lines. Okay, so that's what really wants you to understand. All right. So now, okay, now you can go away and you can do. Well, I don't suppose you have to go away. You can sit where you're sitting, but just carry on the sheet you're doing and do questions 3, 4, 5. I think that should be okay. That should be enough. If you do those, you get understanding. Also, if you have a read of some of the textbooks that are on Moodle, you might see similar stuff to this. There'll be a lot more explanation in those, which you don't need to know. I just want you to sort of focus on doing well on the exam. And also, in a couple of days, I'll put on a practice exam paper for you to try. Okay, but anyway, until then, have a go at that worksheet. Have a watch of this video again if you didn't quite understand it. And I'll see you tomorrow. Okay, good luck.